Thank you, everybody, for coming to my talk here. My name is Iqbal Khan, and I am a technology evangelist at Alachisoft, which is the maker of NCache. Just going to stand here. So today's topic is how to optimize ASP.NET Core performance. I prefer to have a more interactive discussion, so as I'm talking, if you guys have any questions, please raise your hand so we can go ahead. Yeah. Yes, it's going to be. That's what we're doing, is we're trying to record this so that we can then share the link with you on YouTube. So we will get the slides also. We can email you the slides. We're going to have the video up, and then we can also have the slides available so that you guys can share it with your colleagues. Okay, so I think I'm going to get started. It's 1:30. So I'm sure you are here because ASP.NET Core is now the popular technology for developing any new .NET applications or .NET web applications because it has a clean and lightweight architecture. You're probably already on MVC from ASP.NET, but even if that's the case, then moving to ASP.NET Core is going to be pretty easy. ASP.NET Core is lightweight, it's cross-platform, it's open source, and there's a huge legacy ASP.NET user base that makes it a very likely case that most of you guys will be moving to ASP.NET Core. So ASP.NET Core going forward is going to be the choice, the technology choice for .NET for developing high-traffic web applications or high-traffic server applications and web applications. That means ASP.NET Core needs scalability, and I'm sure that's why you're here. Let's get a few definitions understood before we dive into more depth. Number one, what is scalability? Scalability essentially means that if you have an application with 5 users and it performs, super fast, good response times, then if you can maintain the same response time, same performance with 5,000 or 50,000 or 500,000 users, simultaneous users, then your application is scalable. If your application is not performing well with 5 users, then this is not the talk for you. Then you probably need to look at the way you're accessing your database and you're doing your overall programming. This is assuming that you've done a good job developing your application for at least few users, and then you need to know how to scale it. Linear scalability means that you are able to add more servers in production, and as you add more servers, you can, in a linear fashion, add the transaction capacity. So and I'll go into more detail, but what happens is, let's say you start with a 2-server web farm, load balanced. After a certain number of users, those 2 servers are going to max out, and your performance is going to start to slow down. And then you add a 3rd server, and suddenly the capacity should increase by at least one third, or whatever the new formula is. And then when you max out 3 servers, then 4 should again add the incremental. If you're able to do that, then you have a linearly scalable application architecture. If you're not able to do that, then you have a non-linear scalable. Non-linear basically means that after a few servers, adding more servers is not going to make any difference because there's some bottleneck in your application that is preventing it from scaling. So your performance is actually going to drop as you add more load, and drop to the extent where your application might even crash. So you definitely don't want non-linear scalability, which basically means after a certain point there is no scalability. So what type of applications need scalability? These are all server applications. These are your web applications, which is the ASP.NET Core. Web services, again, ASP.NET Core. If you're developing microservices is becoming a big buzzword now. and because of the fact that you can run them in containers, in containerized environment. You can run even ASP.NET Core in containerized environment, but microservices is another very good use case for scalability, or any other server application where you're just processing a lot of transactions on the back end. So if you have any of these types of applications, usually these are customer-facing, outward-facing applications, or at least they're part of the outward-facing application. Let's say if you're a web services application, you may be part of an overall web application, and there's a web services tier, and the same goes with microservices. But they're generally customer-facing or outward-facing application, but not always. If you're a large company, you may have tens of thousands of internal users, but most of the time it's outside things. So, there is a scalability problem, and that's why we're having this conversation today. And the scalability problem is not in your application tier. So you have, if you have a load balanced environment, your application tier scales very linearly. You can add more servers, no problem. It's the database or the data storage. Any type of data that you're storing. That could be your application data, that could be your sessions, that could be any other data that you're storing or fetching. That becomes a bottleneck. And it's for that was one of the reasons why NoSQL databases gained popularity. The problem with NoSQL databases is that they require you to move away from relational databases. And what we've seen that for a lot of situations, in fact, majority of the cases, you can use NoSQL databases for some data, but a lot of data still has to reside in relational databases. So you're still going to use SQL Server or SQL database in Azure. So you need to solve the scalability problem with relational databases. NoSQL databases are not always the answer because you cannot use them. You cannot replace a relational database with a NoSQL database always. And if you can't replace it, if you can't use it, you can't benefit from it. Even if you could use a NoSQL database, they still don't provide the performance that an in-memory distributed cache would. So you would still need a lot of the things that I'm going to be talking about. So let's see what happens actually, and let me go into this. The scalability problem is something that you really don't want to wait until it happens, because if you're developing an application and you're saying, well, it's performing fine today, and it's good for 1,000 users or whatever is the number of users you have, and suddenly your business starts to become popular, you got lots more customers coming your way, your marketing or your business department has done a good job, and suddenly your application starts to slow down. And it's been documented through studies that a slowdown, every 1 second of slowdown in a web application results in revenue loss. Because your customers in a lot of these online businesses, the types of businesses that are online are e-commerce businesses, they're retail businesses with online stores. These could be healthcare, e-government, social media, online gambling, betting, travel industry. A lot of businesses are going online because any business that has to deal with consumers that are going to conduct business with them, these are consumers of tens of thousands, they're usually going to come online with them. And online doesn't always mean a web application, it could also be a web services application because you may have a mobile application that's going to talk to a backend. It's not a good idea to wait until you have scalability problems because then it's going to be very costly to your business. These applications are going to slow down as you saw that non-linear curve. At that time, adding more servers is not going to help. So you need to plan this ahead of time. Make sure your application architecture is correct and is taking advantage of this. It's almost like a mandatory thing as a best practice for you to be incorporating a distributed cache in your application architecture. So how does a distributed cache help? this. I'm going to use NCache as an example here, and NCache is an open source distributed cache for .NET. You can find it on GitHub, and you can also find it on our website. And there's also an enterprise edition. So if you don't have the money or you don't have the budget, go with the open source. If you want a more supported version with some more features than open source, then go with enterprise. So I'm going to use NCache as the example, but I'm not talking about NCache. I'm talking about caching overall. So how does a distributed cache help? Well, let's say in case of NCache, it creates a cluster of 2 or more servers. So as you can see, this middle tier, which is the caching tier, is going to have at least 2 servers, and maybe more than 2, depending on how many servers you have here, how much load you have here. So when you don't have a distributed cache, the database is just one server. You can't really distribute a database, a relational database. I mean, SQL Server and relational databases are trying to improve their performance. For example, they have in-memory tables now. SQL also has read-only replicas of the database so that the reads can be replicated. But the problem with replicas is that every update is that much slower, because every time you update, it's got to be updated 5 places or 4 places. So your application. So it's not the ideal way to solve this. There's a better way, which is the distributed cache. And the reason a distributed cache is scalable is the word distributed. And the reason it can distribute is because it's a key value store. Everything is stored based on a key. Key can easily be hash mapped into multiple partitions, and every partition is a server, and that's how you achieve the distribution. So you have a minimum of 2 cache servers. A typical configuration that we see is about 16 to 32 gig per server as the memory, because again, it's an in-memory store, so you got to have a lot of memory. And it forms a cluster. It's a TCP-based cluster which pools this memory and CPU as a resource of the cluster. So let's say you started out with a web application tier with, let's say, 4 or 6 web servers. So you'll have 2 cache servers, and let's say 16 to 32 gig memory. And now you're starting to get more and more. And 80% of the time you're going to the cache. 20% you're going to go to the database for the updates. It may even be less than 20%, depends on how many updates you're doing. For some data, the updates are more than the others. But let's say, again, you're going to add more servers to the application tier here, and it's going to, again, do what it did to the database. It's going to max out the caching tier because you've got only 2 servers. So let's say you reached about 8 servers in the web farm up here, because, as I said, as you have more users, you have more application servers. So this is going to max out. As soon as it maxes out, you add a 3rd server. And these are not very high-end servers. These are low-cost servers. Usually, a typical server is about 8 core. If you get more than 32 gig of RAM, then you should go to 16 core, because the more RAM you have, more garbage collection it has to do, because of .NET being a managed memory thing, and then you need more processing power. But we recommend to most of our customers, and again, these recommendations also apply to open source, that we recommend to our customers to go between 16 and 32 gig RAM per server, and just add more servers. Instead of getting really high-end few servers, just add more servers. So when 2 servers are maxed out, just add a 3rd one, and the same thing goes, you can add a 4th one and 5th one, and you'll probably never max out, because whatever transaction capacity you need, let's say if you have 20,000, 30,000 concurrent users, that's pretty much on the high end of most web applications. I mean, there may be some which are more, there may be 100,000 plus concurrent users, but if you have 20,000 concurrent users, that means you probably have millions of people coming to your website every day. So, I mean, we're talking that scale. So, because of this, now suddenly the database is no longer the bottleneck. You're caching application data, and it's a common cache. It's a shared cache. So when you put this cache here, because it's an in-memory cache, in-memory means that if any one cache server goes down, you're going to lose data. So that means the cache has to provide intelligent replication, which NCache does, to make sure that if any one server goes down, another server has a copy of that data. But if you make too many copies, that also slows down the whole thing. So NCache only makes one copy of the data, and it partitions. Every partition has a backup on some other server. And then as soon as one server goes down, then it repartitions, makes another copy. And by having a shared cache now, these boxes become stateless. Stateless means there is no data being stored on the application tier. So what you should do is, when you can achieve that goal, that your application tier is stateless, that means you can bring any of the application server down without causing any interference. Let's say you got to apply a patch, operating system patch, or an application upgrade or something. You can just keep applying it here because all the data is either in the database or at this layer, so these can easily be brought down. Any questions on this so far? I'm not able to hear you. What's the backbone for? Yeah. So basically, all of this is in the same subnet. The cache is the goal is to keep the cache as close to your application as possible. For example, so because of that, the network latency is not an issue. For example, when you use NCache in the cloud, let's say in Azure or AWS, you want to keep the cache in the same VNet as your application. You don't want to keep it across multiple hops, because then the network becomes the latency becomes quite noticeable. The performance drops by about 5 times if you go across multiple hops. So we recommend to our customers to keep the cache as close to your application as possible. Did that answer your question? Uh-huh. Okay. I'm not able to completely hear you. My apologies. Okay. So now that we've kind of established the case for why you should use caching, what's the benefit, what problem it solves, and how does it solve that problem? The first question is, what do you use it for? I mean, what are the use cases? Where in the application do you use a distributed cache? Number one is the application data caching. That's the use case that I talked about already, which is that you have a database which has the application data. You cache this data here, in the cache, so that you don't have to go to the database. Now, there's one thing that you got to keep in mind, and I will come back to this, that in application data caching, the data has 2 copies. One is in the master, which is the database, and one is in the cache. Whenever you have that situation where the data lives in 2 places, what could go wrong? Yeah, so the 2 copies could become inconsistent or out of sync. That means the cache could become stale. So any cache that becomes stale forces you to cache only static data, read-only data. And read-only data is only 20% of your total data. 80% is what we call transactional data. So if you cannot cache transactional data, then that cache is going to limit you. And this is where NCache has some really powerful features. And again, all open source. All really powerful features that will help you make sure that the cache always stays fresh. It stays good. And I'll go into that more. Number 2 use case is that, again, app data caching is for ASP.NET Core and also other applications. But for ASP.NET Core, there are at least 2 other uses. One is the sessions, that you can just store your sessions in a distributed cache like NCache. And there's no programming needed to do that, so that's a really, really quick. If you want to get the quickest benefit performance-wise to your application, and let's say your application is already live or it's done, just just start to store your sessions in a distributed cache like NCache. And because there's no programming, there's very little testing that you have to do. You need to do, of course, some basic sanity test to make sure everything is working in your environment, but there's no development effort involved. Because of that, there are no development schedules and no release schedules that are involved in this. So very, very quick. The second ASP.NET Core specific caching is the response caching, which is in ASP.NET, it used to be called output cache. In ASP.NET Core, they've actually made it more standards-based. So it's now, it uses the HTTP-based caching directives that can be understood by third-party edge caching solutions. But it is essentially, you're caching the output of a page. So the next time that page is called, if the output is going to be the same, why execute the page? Why not just deliver the output? Now, that is good in those situations where the output does not change very frequently, which are a lot of cases. But if you have an application which is very dynamic, you probably won't have that much of a static content. But even if you can have it for a short period, that still saves you things. So if ASP.NET Core response caching has a middleware concept, and you can plug in a distributed cache like NCache as a middleware, which basically lives on the same tier as the ASP.NET Core, or it's the same. The middleware cache could be here, and here's the actual ASP.NET Core application. So that's the second biggest, that's common use case for distributed caching. And I'll go into a little bit more detail on these, but I'm just giving you an overview. The third use case is something that a lot of people don't know about, which is that you can do pub/sub messaging and events with a distributed cache. Pub/sub messaging allows multiple applications or multiple instances of your application to coordinate work with each other by sharing data, information in an asynchronous, event-driven manner. For example, so what are some of the examples where you might need this? Microservices. Again, microservices are independent, decoupled services, but they need to coordinate. I mean, one microservice might produce something that is used by other microservices. That's how the workflow is going to be done. But they don't want to depend on each other directly, otherwise the whole model breaks. So then what you do is you actually think of this as no longer a cache for your database, but think of this, and I'm going to actually, just give me one sec, I'm just going to, just for one picture, I'm just going there, not. Think of the distributed cache now as a messaging platform. So the whole paradigm shifts, which is that now you have applications. These could be multiple VMs or containers running your microservices or any other applications, and they can communicate to each other in a pub/sub manner. So they have topics, and so they have publishers and subscribers, and that really simplifies your application. Now, there are other pub/sub solutions like RabbitMQ, MSMQ, messaging queuing mechanism. What's so special about a distributed cache like NCache? Why should you use this over that? The reason for using a distributed cache is because this is very, very fast. It's all in memory. It does not have all the features that a message queue will have, because they also will do persistence and store the messages for long periods of time. But in a lot of situations, you don't need to keep them for that long. If everything is running within the same data center and it's really transactional environment, but you're using this more for a workflow, then replication is more than sufficient. The fact that you have that all of the data is kept on more than one server is more than sufficient to make sure that your messages, your events are not going to be lost. So unlike the application data caching where there were two copies of the data, so the nature of the problem was different. You had to keep the cache fresh. In second and third case, it's the opposite. There's only one copy of the data, which is the cache. Now within the, so that means within the cache, there has to be more than one copy that is consistent for replication purposes. Because if you don't have that, then cache being in memory will lose your data. So you don't want to lose your messages, your sessions, and your page output just because one server goes down. So pub/sub messaging and events is a really powerful use case for a distributed cache. And again, all of this is open source. So there's another feature in NCache called continuous query that actually no other .NET space cache has. Some of the Java caches do have it. And a continuous query allows you to specify an SQL type of a query on the cache. So for example, you could say something like select customers where customer.city is New York. And you say, I'm interested in this data set. So, and you're asking the cache, can you please monitor this data set? So any customer object with this attribute is ever added, updated, or deleted from the cache, please notify me. So now you don't have to watch every object yourself, which you can't anyway. Oh, it's too chatty. The cache will do it for you. It's similar to how SQL Server has SQL dependency. You can ask SQL Server to monitor a data set and notify you when that data set changes. Except that is one or more rows in a table, but here it's objects in a distributed cache. So those are the three common use cases. Any questions that you have on this? No, actually, it's got a complete pub/sub messaging, eventing. There's pub/sub API that you make calls to. So you will do a cache.messaging service.create topic, and you'll create a message with the payload, and you'll publish, and it'll automatically go to all of the subscribers. Complete, yeah, complete. So it simplifies your overall pub/sub usage, but it's super fast because of all being in memory. So by default, you should not need to persist anything because everything has two copies, and there are two copies of separate boxes. And of course, if your IT department or your IT engineers create multiple VMs on the same hardware box, then NCache doesn't know. So then that hardware box dies, and both the VMs will die. So you need to make sure that the redundancy is all the way to the hardware level. That everything is on two separate, independent pieces of VM and hardware. Once you do that, then the probability of both of those going down simultaneously is very, very low. But you can persist stuff. So I'll go into some of the features where you can actually do read-through, write-through. So whatever you're writing can be persisted to a store of your choice. But I would say that if reliability or high availability is your concern, the fact that these are really low-end boxes, you're not spending a lot of money on each box. So these are not like database servers. These are your typical web server configuration, VMs. And so get a minimum of two. But if you want still, you can persist. So actually, we recommend that you keep a separate caching tier. So the actual cache is on a separate set of VMs. There is a subset of that cache that's stored on your application server, and I'll go into that in a bit for more in-proc speed. But because the cache itself is gigabytes, as I said, 16 to 32 gig per box, so you can't really store it within your application process. So that's the other benefit of having a separate caching tier. It's really scalable both in terms of size. If you have a worker process for ASP.NET or ASP.NET Core, how much can you store in that one process? There's a limit, and plus you don't want to make that too heavy anyway, so it's better to have it kept separate. Any other questions?
Yeah, I guess is that part of the NCache product?
Yeah, it's all built into NCache.
It seems to me that they're essentially different. So you can almost retrade the cache from the source, right? That's an application build. When you go wrong, your application is basically broken. How do you ensure that the events are properly stored and sort of played?
Well, actually, so as I said, there's a perception that in-memory is risky, but the reality is that when you replicate, it is not risky. NCache has been around for more than a decade. So our customers use it for years nonstop. It depends on the environment. If everything is within the same data center, if you're not in memory, you're not able to achieve the performance that you need. And replication assures you of the high availability in case any one server goes down. So think of NCache not as a cache. I started with that as the intro. NCache is really an in-memory data store, a distributed data store. So when you have a distributed data store, that data store has built-in redundancy. It has built-in dynamic clustering and high availability. So you've got this infrastructure now. It's like the RAID disks, except it's all in memory. So now that you have that infrastructure, it has multiple use cases. There's one more use case that I didn't even touch, which is full text searching. So let's say NCache is about to release a full text searching feature to make advantages. So we've taken the Lucene.NET and which is the open source, and we've made a distributed Lucene.NET, which is also open source, but which uses NCache. So now you have Lucene distributed across multiple servers, all in memory. So there are multiple use cases, and more are coming. So if you go to machine learning, that also there are many algorithms which are data intensive. Not all, but many of them are. And so why not use an in-memory store? If you don't use in-memory, as soon as you touch disk, everything
I agree with you.
changes. Yeah. Actually, PubSub is very much a messaging platform that your application should be tapping into. In fact, even if you see now, PubSub is being offered as part of the environment. So Microsoft is trying to do a service fabric. There's also MSMQ. There's RabbitMQ. So everybody's trying to offer this thing. But in-memory is going to win for those people who need high performance. Any other questions? Okay. I'm going to skip this and I'll come back to this in the end. Let me just go through. So I think the most common use case is the application data caching. Actually, the word distributed cache is more of a Microsoft ecosystem word. On the Java side, it's called in-memory data grid. We use three words. We use distributed cache, we use in-memory data grid for when we're talking to Java folks, although we're in the Microsoft ecosystem, so we're not that much. And then there's the in-memory, distributed in-memory data store. So application data caching is the distributed caching use case. So how do you make sure that the cache, so if you're going to use application data caching, there are three ways that you can do this. There's an iDistributed cache interface that is available in ASP.NET Core, which is basically, it looks like this here. Very simple interface. Microsoft finally gave an interface that allows you to plug in any distributed cache underneath. The only problem with this is that it's really, really simple. So you can't do much through this. You can just do really basic. And the only thing that it does, it gives you expirations. When you do set, you can specify cache entry option, which are just expirations. So yes, NCache implements this. So if you're programming to distributed cache interface, you can just plug in NCache without any code change, any further code change, and you've done the programming. But I would not recommend that you should do this, because if you're really going to tap into a distributed cache as a benefit, then you want to understand what are all the other features. Why should you not use them? And I'll go over that. Another is if you're doing EF core, again, if you want to minimize the code that you want to write, NCache has an EF core extension methods provider. Let me just quickly show you this. EF entity framework. So EF core extension methods really simplify the way you would use cache. Again, just like distributed cache, the features are not as extensive. So, for example, so let's say that you wanted to. This is your typical EF core or EF link-based query. What we've done is we've implemented a from cache extension method, and there are other extension methods. As soon as you just say that, then behind the scenes, this query will first be looked at in the cache. If the cache has it, you'll get it from the cache. Otherwise, you'll go to the database, get it, and cache it before it gives it to you. So it simplifies your programming quite a bit. If that's something that you want, let's say you have an EF core application already and you want to just plug in as quickly as possible, this is the fastest way to get NCache in. But as you can see, this is the third option is to use NCache API, which is also a fairly straightforward API. NCache API looks almost identical to ASP.NET Cache object, but of course more than that. We've tried when we came out a long time ago. ASP.NET Cache was the only interface or object that was around, so we tried to keep it as close to it as possible. So it's a simple concept. You connect to the cache, you get a cache handle, you do a cache.get, there's an indexer for get, you do contains, you do add, insert, remove, and there are async versions of these so that you don't have to wait for the cache to be updated. There are obviously more than that. So this kind of gives you a flavor of how simple it is to use a cache. Now, the main thing that I wanted to come to was this page. So as I told you, there are two copies of the cache. If your cache is not able to keep itself fresh, you're going to really limit the use. So it's really important to understand that. So what do caches do? Most of the caches provide you expirations. Expiration it's also called TTL, time to live. We call it absolute expiration because that's where ASP.NET Cache object used that term, so we just kept with it. What does it do? You're adding an object to the cache. You're saying, please expire this 5 minutes from now or 10 minutes from now because I think it is safe to cache it for that long. You're making an educated guess, which is fine in some of the reference data cases. For example, you've got a product catalog. It's probably not going to change every 10 minutes. You know, its pricing is not going to change every 10 minutes. So it's more predictable changes. Some of the situations, so it's okay to use expirations there. But if you're caching a customer or an activity, you don't know when that's going to change because a customer is going to call and make some changes. So you may not be able to live off of expirations only. So that's where you need other features in the cache, and this is where all of these features are in NCache as open source. One of the features is that NCache can synchronize itself with database. Now the database could be SQL Server, it could be Oracle, or it could be any OLEDB in case of polling. But synchronization means that NCache becomes a client. The cache server becomes a client of the database. It will now use SQL dependency that I was talking about. The same thing as a continuous query, but for SQL Server. It will use a SQL dependency, and I'll show you how that works. So let's say So when you're adding, let's say you're adding this product object to the cache. So you've got a key and you've got the cache item that contains the product. What you want to do is you want to specify a SQL statement that identifies that specific product in the product table. And again, this SQL statement is for SQL Server, not for NCache. You're passing it to NCache, NCache will pass it to SQL Server. NCache, when it caches this product, it will now notify, it will register with SQL Server a SQL dependency, and then it'll keep the mapping. So if SQL Server sends an event to NCache saying this product was updated in the database, now NCache knows that it's stale in the cache. So it'll do one of two things. It'll either just remove it from the cache. I mean, your application doesn't have to do anything. This is all being done by the cache. Or if you've implemented this feature called read-through, then it will automatically reload the item. So database, and I'll come to read-through in a bit. But so database synchronization is a very, very powerful feature to give you the peace of mind that you can cache all data. Without which, if you're only doing explorations, you're limited. And it's so bad that if you talk to a typical person who knows about caching in a basic manner, the knee-jerk reaction to caching is, oh, that's for read-only data. You know, caching is for static data only. Everybody's afraid to touch transactional data. And that's because of these things, because explorations is nothing more than an educated guess, which may be valid for more predictable cases like product catalog and others, but it is not valid for transactional data. Any questions on this?
The NCache font, assuming it's a new package, right?
Yeah.
Does it actually store your data within the application box? Every call is IO bound.
Every call is an IO bound call, but unless you want to optimize performance, and I'm just going to jump ahead and then come back. NCache has this feature called client cache, which gives you in-proc speed. So a subset of the cache based on your use, every application instance's usage pattern that gets cached within the application process. Now, it's not a disconnected cache. So a client cache is a local cache, but it is connected to the caching tier. So if whatever you have on this box, if let's say this client changes that data here, the caching tier knows that these two boxes maybe have that same data. Okay, they'll notify them. There's a little bit of a latency, a few milliseconds, which is fine in most cases, but there's another option where you can even work around that latency issue, which is called pessimistic sync. But in most cases, it's okay to have maybe 1 or 2 millisecond latency in which you still have the older copy. But a client cache gives you that benefit of performance. That's also something that only NCache has, but by the way, so let me just go back. Okay. So that's one. So the same, if you have a non-relational data source, this could be something in the cloud, it could be a legacy database, it could be mainframe. You could achieve the same goal as SQL dependency, except in that case, you're not event notification based. A custom dependency is something that you implement. It is your code this is server-side code. So NCache has this concept of server-side code that you write that lives on the cache server. Custom dependency is one. Read-through, write-through is another. I just talked about read-through being that you can reload the thing if in a database synchronization, instead of removing the item, NCache can go and reload it. How can it reload? Because it has your read-through code. What does read-through look like? And I'm sort of jumping back and forth, but I wanted to connect these dots. That's why. How do you write a read-through? Is just a simple interface. So you have a read-through interface here. It has three methods. There's an init, which allows you to connect to the data source. Dispose is the disconnect, and there are two overloads of load from source. So load from source is a key, and you give back cache item, and load from source has an overload where you can give back a dictionary. So load from source is something that NCache calls your read-through handler. So let's say your application does a cache.get, and that item is not in the cache, and you tell NCache, well, if it's not in the cache, please go and ask the read-through handler. NCache will call the read-through handler, because read-through handler is your code that lives within the cache cluster. NCache will call this method. This method is your code. It goes to your database, your data source, which may be anything. Could be SQL, Oracle, mainframe, and get the data, and then put it in the cache. Now that NCache has the ability to go to your database, it can do auto reload. And so that's the convenience part. So you can synchronize it with a relational database and non-relational database. The third thing is, if you're caching relational data, you have to do a lot of bookkeeping within your application to keep track of one data has a relationship with another. I'm just going to give an example of a customer having multiple orders. Although you usually don't delete a customer, but let's just say if you did, and the cache doesn't know it. So let's say if you deleted a customer object from the cache and it had 10 orders in the cache, those orders are no longer valid. They should not be kept in the cache. So whenever you have a one-to-many, usually the many depends on the one. So if you delete one from the cache, you should also delete many from the cache. Now it's something that you would have to keep track of. Every time you delete one, you have to go and delete many. So what you can do instead is, what ASP.NET Cache object had was a cache dependency concept, and Cache has implemented this. So you can relate these two, and then if the customer object is ever updated or removed, all of the orders are automatically removed. You can use the cache dependency for one-to-many, for one-to-one, and also if you wanted to cache collections and then store individual objects separately also. So let's say you had a collection of customers as one object cached, and you had some of the customers also individually cached. Because in a cache you can keep multiple copies. It's all being kept by your application. So unlike your database, which has to have normalization and data integrity in that way, cache can have multiple copies because it's all about performance. So when you have multiple copies, then you have to be able to clean up when one copy is updated, and that's what this cache dependency allows you to do. So those are the 4 different ways that you keep your cache fresh. They're all available as part of NCache open source. And as I've gone through read-through, write-through again. Write-through is the same as read-through, except when you update the cache, you ask the cache to go and update the database. So read-through is when you read the cache, you ask the cache to read from the database in case it doesn't have the data. Now, read-through and write-through allow you to consolidate your persistence code into one caching tier and let the cache become more aware of your database, and the application becomes simpler and simpler and simpler. Write-through also has an added benefit, which is called write-behind. That anytime you update the database, you know that's the slowest operation in your application is updating the database. It's even slower than fetching data from the database. And if you're using a cache for fetching data, so you don't have to go to the database that much, why not use the cache for updating the data if the data is not that sensitive? It means that you can queue it up for asynchronous update. If the data is very sensitive, then obviously you don't want to queue it up for asynchronous update. But a lot of the data is, you can queue it up for asynchronous update. When you queue that, basically you do a write-behind feature. You ask NCache to write it to the database in an asynchronous fashion. A queue gets built of multiple update requests. That queue is replicated to multiple servers. In case any one server goes down, that queue is not lost. And your application suddenly speeds up because it's no longer waiting for the database to be updated. So write-through has the performance benefit. Write-behind. Read-through and write-through. Read-through has the auto-reload benefit. You can even auto-reload with expirations. So when you expire, you can automatically reload that item. The expiration basically is saying, I think this is probably changed in the database, so it's no longer valid in the cache. So instead of removing it, why not reload it? Because you're going to need it anyway. Because it's probably some sort of a lookup data. So read through will automatically. Again, the cache takes over more and more of that work from your application. Once you are able to keep the cache fresh, and you're confident, now you start to cache a lot of data. When you start to cache a lot of data, then it's really nice if you can search data beyond just key value pairs. I was just talking to somebody last night, and they were so they had to really come up with techniques on how to format their keys to find different types of data. This is something that you don't have to do in NCache. You can assign these meta tags called groups and subgroups and tags and name tags. This is metadata that you can assign to your objects instead of renaming the keys. These could be metadata, and based on that, you can say, give me everything that has this tag, or these 2 tags, or these 3 tags, or give me everything that belongs to this group. And that's one. Second, you can do SQL queries. Let me show you that. So again, the cache starts to look more and more like a database. So for example, you can say here, select all the products with this name. So now you're doing a search based on an attribute of the product object. Now this is all NCache code. So you will do cache that execute reader, just like SQL Server. It's very similar. You get an iCache reader back, and you just loop through and do your stuff. Now, this is just something, again, makes the cache very, very friendly to you. On one hand, you put a lot of data in the cache. On second, now you can search data from the cache. Any questions? So you would basically use your read-through and write-through handler to talk to a NoSQL database. We don't have a SQL dependency type of feature with a NoSQL database yet. Yeah. Exactly. So you can implement a read-through and write-through handlers that can go to your NoSQL database and fetch the data automatically. It could be NoSQL, it could be any database. It could be Mongo, it could be Cosmos, it could be any. We just cache the data. So there are 2 types of queries. One is that you search the database, and then whatever you got from the database, you cache it. And the next time, if you issue the same query, you first check the cache, because you say, okay, its results were just recently fetched, so let me just get it from the cache. The second use case is where you preload the cache with an entire data set of reference data. And in that case, you don't ever go to the database, you only search the cache. So NCache will provide you both options. As soon as you go seek SQL or link type of queries, you can do one of these 2 things. Yeah, in case of SQL dependency, NCache is essentially asking SQL Server to monitor that data set and notify NCache when that data changes. No, it's SQL Server is the one monitoring, because that data could be changed through a database script. I mean, it doesn't even have to be a .NET application. It can be a database script that just did an update statement, update whatever, and then now SQL Server is monitoring it. SQL Server notifies NCache, and now NCache has the decision. If it has the read-through handler, it'll reload it. Otherwise, it'll just remove it from the cache. Right. Exactly. Good. Okay. I've talked about the ASP.NET Core sessions. I think the main thing to keep in mind, there are 2 ways that you can use it. One is that you use, you plug in NCache. NCache has implemented an I-distributed cache provider. So you plug in NCache as an I-distributed cache provider, and ASP.NET Core automatically starts to store the sessions in NCache. Let me see if I have it here. This is the other one. Yeah, so for example, here's an ASP.NET Core application. You go to the configure services, and you've just added NCache as an I-distributed cache provider, and now you're using the regular ASP.NET Core sessions, which know that they need to just depend on I-distributed cache, because they know that there's a provider now plugged in. So when you do this, all of the sessions will be saved in NCache. And I'm going to show you what cache looks like. I'm just going to give you an actual demo of NCache. But so that's one way. The second way is that you actually use NCache as its own provider of session itself. So you, instead of going through I-distributed cache, you go into the same configure services and you say add NCache session provider. Now this session provider has more features than the regular I-distributed cache. It has more session-specific features. So I mean, I would recommend use the NCache's own session provider that has then good to go with I-distributed cache. But you can go through both options. ASP.NET Core provides you this. As I said, this requires nothing more than that code change. That's all. Everything else is automatic. So if you're going to benefit from a distributed cache like NCache, plug this in as the entry point into your application. Get the benefit today, because the object caching or application data caching is going to still take programming. It's going to fit into your development schedules, and it's going to be a slightly longer process than this. But this is done very, very quickly. And I've showed you this already here. And this is the config. So again, I'll go over. And the same way, response caching uses I-distributed cache, and you can plug in NCache through that, and then it automatically works. Let me just quickly go. Before I go into the, actually, let me go into this. So we talked about PubSub messaging. So continuous query is also something we talked about. Let me quickly go into some of the things that NCache will do. A distributed cache is something that is like a database. You know, it's living in production with your application. So you need to make sure that its architecture is flexible, is highly available. So for example, NCache has a peer-to-peer architecture that other caches like Redis do not have. So instead of having a master slave, you want to have a peer-to-peer. As I said, a lot of the Java caches, which they call in-memory data grid, have peer-to-peer architecture. The nice thing about peer-to-peer is everybody is a peer, so any node can go down and nothing happens. Problem with master slave is the slave cannot become a master. So if master dies, slave is still a slave. So then it requires manual intervention for you to recover. In case of peer-to-peer, it automatically recovers. Because of peer-to-peer, it becomes what we call a self-healing dynamic cluster. It automatically adjusts itself. So that's the first aspect. The second aspect is linear scalability, which is that partitioning, and again, linear scalability with dynamic adjustment of partition. So one of the things that NCache does automatically is, let's say if you have a 2-server configuration and you want to add, so that's 2 partitions, and now you want to add a 3rd server, so that's a 3rd partition being added. NCache automatically, so let's say it goes from, let's say you have 2 servers here with 2 partitions. Every partition has a backup onto a different server, and a partition essentially is a collection of buckets with hash map distribution. So let's say if you have 1,000 buckets, 500 will go into partition 1, 500 will go into partition 2. Everything is working fine. Now you want to add a 3rd server. at runtime because again so at runtime by adding a third server, now you're going to have 3 partitions. So what NCache will do automatically behind the scenes while the application is running is it'll create a third partition and it'll move some of the data from partition 1 and 2 into third partition. Again, 1/3, 1/3, 1/3. So the buckets actually move. And all of that happens dynamically. Once the buckets move, then the replicas are also readjusted. Replica 1 and 2 are no longer the same replicas that they were previously because they have less data. And there's a new replica called replica 3. The server which had replica 2 no longer has replica 2, it is going to have replica 3, and replica 3 is going to be created on the third server. All of that's done automatically for you. So that dynamism is what makes it highly available. So when you're adding a server, there's a manual intervention so that you have to really, but still very convenient if you can just go and do that, and literally you just say add and everything is done for you. But it's even more important when you're dropping a server, because dropping could also happen because of server crashing. So when you're in 3 server configuration, let's say server 3 goes down, now partition 3 is lost. What NCache will do is it'll immediately make replica 3 active because that has copy of partition 3. So now you have partition 1, partition 2, and replica 3 becomes partition 3 temporarily so that there is no interruption. Once that is done, then NCache now realizes there are only 2 servers, so it can't really have 3 partitions. So it merges replica 3 into partition 1 and 2, all at runtime. And then once that merging is done, it now creates a replica 2 at this place here. And now so you can go back to this picture. Now this is something that with other caches you cannot do automatically. What that means is that if this thing happened in the middle of the night, one of your IT department people will have to manually go and readjust. And until that happens, the cache will run in what they call limited functionality. But in case of NCache, it automatically adjusts itself. So that you need to make sure high availability is really there in a cache. And I've talked about the in-proc speed already. There's another feature. Now, this is a feature for Enterprise Edition, which is that if you have multiple data centers, which a lot of applications now do, because of the cloud, it's even easier to procure in just multiple regions. So if your application is in multiple data centers, your cache may also need to be replicated to multiple. And because there's a lot of latency, you can't really have the entire cluster span multiple regions. So you got to have a cluster in one and a cluster in another, and there's a bridge in between, which asynchronously replicates. So it's a two-way replication in case of active-active, and the bridge does conflict resolution, because if the same key is updated in both places, now you have to keep track of that. I think I have another 10-15 minutes, so I'm going to now quickly do any questions before I do an NCache demo? Yeah, so actually, when the applications, let's say here's the picture. So every application server, in order to connect to the cache cluster, needs to know of at least one server in the cluster. So let's say, and once it connects to that server, the first thing that server does, it gives it what we call cluster membership information. So that cluster membership information is now used by that client to automatically connect to all the servers. Again, all of that's happening transparent to your application. This is all NCache's client API. And similarly, if you go from a 2-server to a 3-server thing, now the membership has changed. So now you have a 3rd server. So the updated membership will be sent to all the clients, which will now connect to the 3rd server.
So all connections are being used, or is it just one and then
no. All of them are being used because it's partitioned, so it's distributed, it's load balanced. Some data is in partition 1, some is in partition 2, some is in partition 3. So it's all one hop. The whole idea is that you should get your data in one call, one hop. So if you don't go directly where the data is, then you'll first go here and then it'll go and get it for you, right? which is 2 hops, which is not as fast.
That's done by that client.
Yeah, exactly. It's all transparent.
One of my cache servers, and the rest of them, or do I have split it up?
Every application server, every client will talk to all the cache servers. And depending on which one has the data. Because again, keep in mind the data is partitioned. Exactly. It will know immediately where the data is. If one server is down, it'll readjust the membership and it'll connect. So let's say if you were a 3-server cluster, this one went down, now you're a 2-1, so now your application will automatically know that there are 500 buckets in this, 500 buckets in this. All of that's hidden from you. It's all done by that NuGet package, the client. Let me quickly show you what NCache looks like. So I've got Azure, so I've basically procured or provisioned, if I can just get the portal, there it is. So I've got, it's really slow. Come on. Taking forever. Anyway, okay, so we have 4 VMs in this, and I'm logged into one of them, which is so I've got 2 cache servers. These are all Windows, 1 cache client, Windows, 1 cache client, which is Linux. Because it's .NET Core, I can do all. So even the cache servers can be Linux. Because NCache, as I said, is .NET Core. So you can just go, when you come to our website, so this, you can actually download either the MSI or the tar.gz. So depending on your preference, you can either install it for Windows or for Linux.
So you guys provide the enterprise.
Actually, so you can download open source also from here. If
Your company, got
our enterprise is built on top of our open source. So we're the owners of open source and enterprise both. Open source is on GitHub. So if I were to come here, so open source you can download free, no registration required, and there's GitHub. So that's the open source. So as I said, all of the features are, the API is the same for both. But because you like us so much, you want to just pay us money. I'm just kidding. Actually, so if you come to our website, there's an edition comparison. So as you can see, most of the APIs are so if you start from here, it's all in open source is this one, so it's pretty much the same. But what happens is there's just a few that are not. For example, you have the cache management, all of the GUI tools, and security, and a bunch of other things are not there in open source. But then also on the caching topology side, this partition replica, partition topology is in open source, but partition replica isn't. So we have replication in open source, which is not as scalable as the partition replica. So, and of course, so there's So there's these types of extra features. You've got the better tools, security, partition replica for more scalable replication, and support, and 24/7 support. All of that is in enterprise. Obviously, open source is as is basis is only supported through the forums. So in my picture, everything, so this is open source, this isn't. No. And for example, this is not open source. So, as I said, all of the developer features are open source, then there are extra bells and whistles in performance, scalability that are not open source. So the idea is that if you're a developer that wants to start a project and you don't have the budget approved, go with open source. If your manager is comfortable going live with open source, go live with open source. If your manager is not comfortable going live with open source, you can at any point shift to enterprise. As I said, because the API is the same, most of these features are behind-the-scenes features. You'll still need to uninstall and reinstall, but you won't have to reprogram your application. Yeah. Enterprise, I think that, I don't know, what is it that you want to say? I don't even know if we're allowed to say this here or not. Yeah, let's try, yeah. Yeah, I don't think I'm allowed to talk price here because it's a talk. Yeah, but you can talk to him afterwards. But it's not very expensive. I mean, compared to Java land, it's much cheaper. And in the cloud, the cost is close to what. So there's an NCache. So we have in Google Groups, there's an NCache group that you post questions to. We also answer, the other people will also answer. So, but with the enterprise, you've got, yeah, you can call, and there's also 24/7 that you can call. We have Java client also, and we're going to be later this year releasing other languages like Node.js, Ruby, and Python and PHP. So let me quickly now, sorry about this. So I'm going to create 2 node cache cluster. Again, this tool is not open source, but all of this stuff you can do in open source. It's just not as pretty. Even this, actually this is going to be a web-based tool now. So I'm just going to go ahead and add. This is my first cache server. This is my second cache server. So I've got a 2 server cache cluster. I will take all the other defaults as is. I'm going to go ahead and add 2 clients. One is myself, which is the Windows client, and the second one I will add as 10.0.0.7. That's the Linux client. I'm going to start the cache. I mean, this is how quick it is for you to create and configure caches. Okay, I'm going to start my performance stats on this. So NCache comes with this program called stress test tool, which allows you to simulate load on NCache. So this is like a program it just gets and puts to it. So I have PowerShell opened here, so I'm gonna do test stress, and I'll specify the cache name, which is the cache name I just gave here, right here. And I'm right now, this box is this first one. So I'm on a client box. So I'm just gonna run this, and you'll see that suddenly activity starts here. So I'm doing about 500 operations per second per box right now. Okay. So let's say I want to increase my load, because I want to test how NCache is going to perform in my environment. So I'm going to go ahead and launch another instance of the same on the same box. Suddenly you'll see that my load has gone up to almost double. And now I have two Linux boxes. As you can see here, this is Linux. This is the .7 box, which is right here. So I'm going to do this. I'm going to first start PowerShell here. I'm going to just quickly copy this module. And I will do the same stress test demo cache. And as soon as I do this, you'll see this has suddenly gone up to be about 60. So every time I do this, about 500 operations per second per box is being added. I'm going to do one more, and then we're going to be done. I will PowerShell here. Here. You'll see that's going to go up. There it is. So you can keep adding more and more load until you see that it'll start to max out, and then you add a third server. And of course, you need to also add more clients. So it's, all of this is perfmon that you can easily just monitor, even in third-party tools. This is as simple as it is to. These are cached items that you're adding. You can go ahead to our website, download either the open source. So open source is available. There's an MSI installer also that you can download open source. So you can either go and download open source, or if you're really sure that you're going to use it in a supported environment, just go ahead and straight away download enterprise. Let's say if I were to come to open source, so you can download the installer. That way you don't have to build the source code again, although all that source code is on GitHub. Any questions, guys? Thank you very much. Thank you.